NVIDIA, the company propelling the AI race, has just launched an incredible new tool presented in a research paper that focuses on text-to-video. Before diving into this groundbreaking research and its examples and applications, recall yesterday's video, where many comments suggested that text-to-video was still a distant reality and rapid advancements weren't imminent. However, right on time, another novel AI software research paper has arrived, and we'll delve into it thoroughly. The paper begins by discussing high-resolution video synthesis using latent diffusion models, essentially meaning that text-to-video is created with models like stable diffusion. The first example demonstrates this quite well, with the prompt at the bottom stating, "Sunset time-lapse at the beach, moving clouds and colors in the sky, 4K high resolution." This seems remarkably realistic for text-to-video generation. While not all examples are as impressive as this one, it's a testament to the rapid progress of AI in fields we once thought impossible, such as text-to-video. To better understand how this technology works, we can turn to the abstract of the research paper, which contains a lot of information. The highlighted portion explains that the state-of-the-art text-to-image LDM stable diffusion has been converted into an efficient and expressive text-to-video model with a resolution of up to 1280 by 2048. Essentially, they've transformed stable diffusion into a text-to-video editor, yielding quite impressive results. Though the release date is uncertain as it's still being fine-tuned, we can examine more examples provided in the research paper. As we explore these examples, a common theme emerges, indicating that some types of text-to-video work better than others. One such example is a prompt featuring a teddy bear playing the guitar, high-definition 4K. This was a standout favorite, clearly employing stable diffusion to generate the video. As we continue analyzing these examples, we gain further insight into the capabilities and limitations of the text-to-video technology. Some videos are more successful than others, suggesting that there's still room for growth and improvement in this area. The teddy bear example is just one among many provided in the research paper, demonstrating the potential of stable diffusion in generating video content. While it's not perfect, it shows significant progress in the field of text-to-video generation and the potential for future advancements. As we explore more examples and observe the rapid development of AI technology, it becomes apparent that text-to-video generation may soon become more sophisticated and widely applicable. As models like stable diffusion continue to evolve, the future of text-to-video seems promising, offering exciting opportunities for various applications across industries. In conclusion, NVIDIA's innovative research paper on text-to-video generation showcases the potential of AI in the realm of video synthesis. Although there are still challenges to overcome, such as refining the quality and effectiveness of the generated videos, the progress made thus far is undeniable. As AI technology continues to advance, we can expect to see further improvements in text-to-video generation, opening up new possibilities for its application in numerous fields. Naturally, this isn't the finest example of a video, but it does demonstrate progress compared to what we saw in yesterday's video on Google's DreamX paper. It's fascinating to see stable diffusion employed in this context, as it appears that various text-to-video editors approach the process differently. An intriguing example features a stormtrooper vacuuming on the beach. While it's not terrible, it's important to note that it's far from film-level production quality. However, considering the early stages of DALL-E 2 and its subsequent progress, we can anticipate improvements in this type of video generation. Another captivating example is a fantasy landscape trending on ArtStation in 4K high resolution. It stands out as one of the better samples and, though not entirely realistic, could potentially be used for in-game loading screens, cinematics, or tranquil YouTube videos if the quality were improved in certain areas. An additional example features a turtle swimming in the ocean. It appears that text-to-video models struggle with rendering moving elements, such as animals in motion. Although not as refined as Midjourney's level quality, this example still offers an early glimpse into the technology's future potential. Another appealing example showcases a close-up of grapes on a rotating table in high definition. It looks reasonably good, but one common issue in many of these images is the presence of grain, which ideally should be addressed in future iterations. Regardless, these examples provide valuable insight into the ongoing advancements in text-to-video generation. I must admit, this example appears rather decent, considering the text prompt provided. One particularly intriguing and amusing example features a koala bear playing a piano in the forest. While not perfect, it demonstrates the AI's attempt to interpret the prompt. Stay tuned for more examples and an exciting feature NVIDIA released with this software. Another favorite of mine depicts a traveler walking alone in a misty forest at sunset. The background, showcasing a beautiful misty sunset, is captured quite well, likely due to stable diffusion. However, the motion of the character walking on the left isn't perfect. With some fine-tuning, this example could eventually reach perfection. The last example I'll share before discussing NVIDIA's impressive release is a time-lapse of aurora in the sky at 4K resolution. It seems that when it comes to fantasy landscapes or time-lapses, the text-to-video software excels. Alongside these examples, NVIDIA included a fascinating feature in their research paper that offers numerous use cases. One notable addition is the concept of personalized video generation. Currently displayed on screen is Dream Booth, which focuses on fine-tuning text-to-image diffusion models for subject-driven video generation. This innovative approach presents a myriad of potential applications for users seeking customized video content. Essentially, this means that if you input a specific number of images, the software can generate various scenes featuring that object in different locations. For instance, in the example displayed, a dog is placed in random settings, such as a doghouse, a bucket, underwater, or even getting a haircut. This capability opens up numerous applications, as users can virtually place their desired objects in various locations without physically visiting those places. The potential for diverse creations is immense. The reason I mentioned Dream Booth, an existing technology, is because they attempted a similar approach with the AI video creator. In this case, the training images used featured Kermit the Frog. The text prompt provided was an SKS frog playing a guitar in a band, with SKS referring to the specific object, in this case, Kermit the Frog. Although the resulting image doesn't appear extremely realistic, the generated output is more convincing than some of the earlier moving examples. It becomes evident that when you provide a driving image, the outcome tends to be of superior quality compared to those without such guidance. This demonstrates the potential for further advancements in personalized video generation using AI technology. In this example, Kermit the Frog is shown writing a scientific research paper. Despite the imperfect animations and background, the AI produces a highly realistic visual representation of the character. This demonstrates the AI's ability to place the subject within the video accurately. Another fascinating example involves a teapot with multiple colors. Despite the complexity of the object, the AI manages to generate a video based on the text prompt, an SKS teapot floating in the ocean. The output appears quite decent, with convincing ripples around the teapot. Additionally, they explored real-world driving video scene generation, training the video LDM on such scenarios. The generated videos, some lasting up to 5 minutes, exhibit impressive realism, despite minor distortion on passing cars and slight manipulation of trees and highways. Moreover, they experimented with creating specific driving scenario simulations. By building an image with various elements, they were able to generate videos based on desired scenarios. This has potential applications for new drivers who may want to simulate specific situations. With rapid advancements in AI technology, it's interesting to consider whether future text-to-video generators will rely on the mid-journey method instead of stable diffusion. Currently, mid-journey is at a stage where it might not need further improvement for image generation, given its high quality. It remains to be seen where both Mid-Journey and other AI models will head next in the ever-evolving landscape of artificial intelligence. Since Mid-Journey has reached a point where it seems to require no further improvements, it is considered complete, as it can essentially accomplish anything in terms of image generation and quality. It will be fascinating to observe where Mid-Journey goes next and how other models will progress in the future.